Okay, so all these problems involve circumference and radii and arc length and sector area, all for circles. So the first problem we have is we're given a circle with a radius of 9. We want to know the circumference in terms of pi, which means that our answer should have pi in it and have no decimals whatsoever. So the formula for circumference is 2 times pi times the radius. So with a quick substitution, we can replace r with the number 9. We get an exact answer of 18 pi centimeters. That is the answer in terms of pi. Okay, next we have given a radius. What is the area in terms of pi? So here we have a radius of 4. Great looking circle. And we want an area, which is the formula pi times radius squared. So we simply replace the radius with 4, and we're only squaring the radius. And we traditionally put the number in front of the symbol pi rather than pi 16, even though it technically is the same thing. Put the pi after the number, and your units are square inches. So now we're given a circumference. We want the circumference is 24 pi inches all the way around the circle. So the question is, what is the area? So in order to calculate the area, we need to know the radius. Okay. So the radius we're going to calculate from the circumference. We're given a circumference. Circumference is 2 times pi times radius. So if I solve this for r, divide both sides by 2 pi. The pi's divide the pi's, and then the numbers will divide the numbers. And I find that the radius of this circle, with a circumference of 24 pi, is 12 inches. So now that I know the radius, check, I can find the area, which is pi times the radius, in this case 12, squared. We square 12 and get 144 pi square inches. Now, just for fun, let's plug this into our calculator so that we can get a decimal approximation, which is approximately 452.389, depending on how many places you want to round to. That's rounding the 3 decimal places. Okay, in this fourth one, we're given an area, and we're asked for the circumference. And now we're told to round in 3 decimal places, so we don't need to worry about having pi in it. So we're given an area formula. We still need to find r. So we need to know the radius, calculate radius. So given an area, we set it equal to pi times radius squared. So our first step would be to divide both sides by pi. Okay, don't worry, your calculator can handle this. R squared equals, let me see if my calculator can handle it. 96.142 divided by pi is 30 with a bunch of decimals. 6029 ... I'm sure there's more.
You got 9?
So I take the square root now. Take the square root of r. Get r by itself. Nope, there's nothing there. So square roots of that is 5.53199, and I'm sure a bunch of other stuff after that as well. Okay, so we don't want to round just yet because we have one more thing to do, and that is find the circumference. So 2 times pi times whatever your calculator says, so you should be leaving this number in your calculator when you multiply it by 2 and then by pi again. That way we keep all of our digits and we don't get any error due to rounding. So 759 would be when you round it to 3 decimals. Okay, so watch the rounding as you go through your problem. You only want to round at the very, very end. So here we have a radius of 9, so let's write that in here, there's 9. And we have a central angle of 120. We want to know what is the length of this arc that is subtended by these 2 radii. How long is the arc? So the distance around the outside. Not the 120-degree angle, that's the measure of the arc. We want to know how long it is. So we use the ratio arc length over circumference, which is 2 times pi times the radius of 9. So an arc length is part of the circumference, just like the central angle that is used is a part of the whole entire 360-degree circle. Okay, so this is in degrees. This is the correct comparison or ratio in proportion that we use anytime you want to solve an arc length problem. You have to know the radius, you have to know an angle in order to find the arc length. Okay, so now we'll solve by cross multiplying. And I'm just going to refer to arc length as x. Okay, put in a variable there rather than writing arc length the whole time. And 18, which is 2 times 9 times pi times 120. We can leave it in terms of pi, that will be just fine. In case we come up with a really awkward decimal and then decimal will be fine. So the arc length, I'm going to multiply 18 times 120 and divide it by 360. Hopefully it's a whole number. And it is. So that arc length is 6 pi centimeters long. So if I times that by pi, that can be approximately 18.849 or 85 would be a good approximation for this arc length. Let's draw a picture here. We know that the radius is 5. So here's 5. And we know that the arc is 12.25. That's more than twice as long. Let's put it there maybe. And the question says, what is the angle? Now we're looking for this. What is the angle that has this arc length as its intercepted side? So we use the arc length formula, which says arc length, so we know that, divided by circumference, which is 2 times pi times the radius of 5, is equal to the degree. So now we're looking for the degree of this, that's your variable, over 360. Okay, we're looking for the arc. This is your variable, that is where the arc goes. So we solve this proportion by cross multiplying. 12.25 times 360 is 4410. And 10 pi x on the right side. And I cross multiply 2 times 5 is 10 with the pi. And then to get rid of, or get x by itself, I'm going to divide both sides by 10 pi all at once. Okay, now if you're going to do this in your calculator, I would advise you to put parentheses around it so that your calculator knows you're dividing by 10 times pi rather than just dividing by 10 and timesing by pi. The calculator has a tendency to forget about that sometimes. So 140.4 degrees would be the angle that gives you a 12¼ millimeter length with a radius of 5. So here we have a circle with a radius of 10. So we have 10 here. And a 50-degree arc. So there's our 50 degrees. And we want to know what is the area of this sector. So a sector is like a slice or a part of the area formed by 2 radii and the curved part of your circle. So we're going to find the area of this sector by using the same kind of proportion as we've been doing. So we want sector area. So sector area is a portion of the entire area. We find area by doing pi r squared. Yes, keep it in terms of pi will be fine. And so no, we want to round it to decimals, but we'll do that at the end. So we have a 50-degree arc, and that is compared to 360 degrees. So we're comparing part of the area to the entire area. That equals part of the arc to the entire arc, 360. Okay, so once again, we cross multiply. 360 times x, your sector area, equals 100, 10 squared, times pi times 50. Okay, the angle that we're talking about. So 10 squared became 100, still have my pi, and then still my 50. So I divide everything by 360, and this is all going to go into my calculator all at one time, including the pi. Let's see what I get. 100 times pi times 50 is a large number. Dividing that by 360, you get approximately 43.63 square miles would be the area of the sector, with a radius of 10 and an central arc of 50.